Concept 30, Probability of Compound Events, Part 2 and Day 2. Look on your note sheet and go to the definition section where you see compound probability. Get down the definition of this. Finding a compound probability is the likelihood that two or more events will occur. It's different from simple probability because in that situation we just figure the chances that one event will occur. There are two types of compound probability. If you're still looking in your definitions section, you'll see just underneath the definition of compound probability that you have the compound probability that use the word or. In a situation like this, you're asking yourselves, what's the chances that something or something else will happen? The first question that you need to ask yourself is, are the outcomes, what you're looking for, are they mutually exclusive? That means they cannot happen at the same time, they can't occur together. Or are they overlapping, so they can occur together? Because depending on your answer to that, you have to figure that probability differently. So look at the example now down in the notes section under compound probability that say or. So the example says you roll a die. What's the probability that you roll a 3 or an even number? So think about how many of those chances that you have. So on a die, you have one chance to roll a 3. So we can express that probability. You have one out of 6. So we can show that as 1 because there's one number 3 on a die out of 6. And then an even number, there are 3 even numbers on a die. So that's 3 possibilities out of 6. Now when you're trying to find the probability of something or something else happening, you add the probabilities. So that is 4 out of 6. Or we can write that as a decimal, which is 0.67 or 67%. And in lowest terms, that fraction would be 2/3. And again, that was when our events were mutually exclusive. I don't think I mentioned that, because as we look at even numbers, 2, 4, 6, we can see that those numbers are different from an odd number. So we don't have any of the outcomes that will occur in both those situations. So this is a mutually exclusive situation, so we simply add the probabilities and go with that. Go back to your vocabulary definitions and formula section under the compound events that say or, where it says mutually exclusive, and list this formula first. So capital P means probability of A or B. A is just the first event, so one event that you're looking for. In the example we just looked at, it was rolling a 3. B is the second event. And that, in the example we just looked at, was rolling an even number. And so equals, the formula is saying you find the probability that the first event will happen and add it to the probability of the second event. So write that as the formula. Now let's look at the next example. You roll a number cube. What is the probability that you roll an odd or a prime number? So first of all, let's think about that first question. Are the outcomes mutually exclusive or overlapping? So let's look at those possible outcomes. An odd number on a die is 1, 3, and 5. Those are our odd numbers. So that's 3 possibilities out of 6. Prime numbers are 2, 3, and 5. So that is 3 out of 6. But we do have some of those outcomes that overlap, 3 and 5. So this situation is overlapping. And the overlapping are 2 of those, 2 out of 6. So when we figure the probability, we're going to take the probability of prime numbers, add it to the probability of rolling an odd number, and then subtract the probability of something being both, because we do not want the chances of both happening. We want the chances of one or the other occurring. So that will give us 4/6. As a decimal, well, first of all, reduce, that would be 2/3. And then as a decimal, that's 0.67, and as a percent, that's 67%. When we figure probability, we'll express it in all three ways: as a fraction or a ratio, a decimal, and a percent. Now go back on your notes to the vocabulary definitions and formulas section, and under compound events that say or, under overlapping, write this formula down, and let me explain it. So the probability of an event, remember these are different events, A or B occurring, will equals the probability of the first event plus the probability of the second event minus the probability of the overlap of those events. Now we're talking about the second type of compound probability events, and those are ones that use the word, or sometimes they imply the word and. So in your next example, you draw a marble out of a bag of 16 marbles, 5 red, 11 blue, and then you replace the marble and draw out another. What is the probability of drawing 1 red and, see the word and, 1 blue? First ask, are these events independent? That means one probability does not affect the other, or dependent. One event does affect the other. Well, in this situation, if you replace the first marble that you draw out, you are not affecting your second draw because you still have the same total. So these events are independent when you replace the first marble before you draw the second. So to figure the probability, you first do the probability of the first event, so that red is 5 out of 16, and then in this case you want the probability that both will occur. So we need to multiply, and then 1 blue, and there are 11. So we'll do 11, since we replaced, we have 16. So we multiply straight across, and we get 55 over 256. And that will reduce to let's try. What we see, it's 55 over 256. Is it in reduced form? The decimal is 0.21, or a 21% chance of that happening. Now go back to your vocabulary definitions and formula section, and under compound events that say and, if an event is independent, here is the formula that you use. To find the probability of A and B occurring, you multiply the probability of A times the probability of B. Now let's look at this event when we do not replace the marble. So you draw a marble out of a bag of 16 with 5 red and 11 blue. You don't replace it, and then you draw out another marble. Sorry about that. What's the probability of drawing 1 red and 1 blue? So in this case, these are dependent because one does affect the other. So for red, we've got 5 chances out of 16. We're still going to multiply. For blue, we have 11 out of 16. And I'm sorry about that. We actually did not replace, so we have 11 out of 15. So now that affects our total. So we will have 55 out of 240. That reduces to 11/48, or we could write that as a decimal, 0.23, or a 23% chance of that happening. Here's a final recap on probability with compound events. So if your compound event says or, what's the chances of something or something happening? You first ask, are the events mutually exclusive, meaning they can't occur at the same time, or overlapping, they can occur at the same time? If they can't, if they're exclusive, then you just add the probabilities. If they're overlapping, you add the probabilities and then subtract the chances of those overlapping events. If you're finding compound probability with problems that say and, first ask yourself, are the events independent, meaning one does not affect the other, or they're dependent? If they're independent, you simply multiply their probabilities. If they're dependent, you multiply the first probability times the second probability given that the first one has happened, which usually means adjusting the total on that second event. And that's how you do compound probability.